Section 4.7, using corresponding parts of congruent triangles. Here, we're given in each diagram, the red and blue triangles are congruent. We want to identify their common side and or angle. We want to use this type of information when we do proofs because we can use the reflexive property to help us get triangles congruent. On our first diagram, we have triangle ABE congruent to triangle ECB. We have a common side on both triangles, and that common side is segment BC. Here we're given two triangles. The red is over top of the blue one, but I think we can identify that the triangles are BAE and CAD, and we have a common angle that is in each triangle. That would be angle A, or also angle DAE. On this slide, they want us to separate and redraw the indicated triangles. We want to identify any common parts. We have triangle ABD, which ABD is the bottom left triangle in the big triangle. So that would be triangle ABD. And triangle DCA. And we have a common part in both of them. We actually have a segment, and that segment is segment AD. Here we're given another diagram following the same directions. We're given triangle ABC. Here we have ABC. And triangle ABD. And the common part in these two triangles is segment AB. What we want to do now is use the information from our previous slides on overlapping triangles and CPCTC and our properties of congruence for triangles to solve this proof. Here we're given segment PS congruent to segment RS, identified by tick marks in our diagram. Here we're given angle PSQ congruent to angle RSQ, also identified in our diagram, but here with arcs. We want to prove triangle QPT congruent to triangle QRT. The way we're going to do that is we're going to get these two triangles congruent, PST and RST, and then use other properties such as CPCTC to get parts of this triangle congruent, and then use our properties of congruence of triangles to solve the problem. So let's start getting these two bottom triangles congruent. That's not going to be too difficult because I can state ST congruent to segment ST by the reflexive property. Now, with that segment congruent to itself, I can state the triangle PST is congruent to triangle RST, remembering your triangle correspondences, by the method of side, angle, side. Next, I can then get segment PT congruent to segment TR. By CPCTC. Later in the proof, I can state that segment QT is congruent to segment QT by reflexive, but that's only going to give me two segments of the triangle. I either need another segment or an angle. There is another way to get segments, and we'll talk about that later. But let's take a look at a way to identify angles congruent. If I label these two angles 1 and 2, I can state on step 4 that angle 1 is congruent to angle 2 by the same method, CPCTC. I then can number this angle, 3, which is PTQ, and RTQ, angle 4. I can then use a long method of stating angle 1 plus angle 3 is equal to 180, and angle 2 plus angle 4 is equal to 180, either by the angle addition postulate, definition of a linear pair, or definition of supplementary angles. Then, on the next step, I could set these two equal, angle 1 plus 3 equal to 2 plus 4, by substitution, subtract out these two congruent angles, which I've already proved in step 4, and then state that angle 3 is congruent to angle 4. But we have a property that we have identified earlier that states I have two angles, 3 and 4, that are supplementary to two angles that are congruent or the same angle. And if that is true, then these two angles must be congruent, and congruent by the method that I just stated. Therefore, the shortcut method would be, if I have two angles, which would be 3 and 4, supplementary to congruent angles, which would be 1 and 2, then the angles are congruent. Now that gives me angle 3 congruent to angle 4. Then I can state that segment QT is congruent to segment QT by reflexive. And on step 7, that gives me my triangle congruency, triangle QPT, congruent to triangle QRT by side, angle, side. Let's take a look at the method of solving this proof a different way. I won't formally write down the problem, but we'll just discuss it. We already solved this by stating triangle PST is congruent to RST by side, angle, side. And we did that by getting segment ST congruent to itself by reflexive property. Then that got us PT congruent to RT by CPCTC. We could have went back and stated QS congruent to QS by the reflexive, which would have given me PSQ congruent to RSQ by the same method, side, angle, side. Then I could have stated that PQ is congruent to RQ by CPCTC. Then I could have used QT congruent to QT by reflexive property. Then I could have stated the triangle congruence by side, side, side. Just a different way of solving the proof. Our next proof can be difficult because of the multiple overlapping triangles. So what I did is I did draw an alternate diagram of the triangles I need to prove congruent first. So let's take a look at the given and what I need to prove and why I generated this diagram below. Here I'm given angle CAD, which is CAD, congruent to angle EAD. Then I'm also given the angle C is congruent to angle E. But I need to prove segment BD congruent to segment FD. And here is BD and FD. The way I'm going to attack this problem is I'm going to get triangle EAD congruent to triangle CAD. When that happens, I can get segment DE congruent to segment CD. Then I can prove these two angles congruent by the vertical angle theorem and get those two little triangles congruent and then prove FD congruent to BD by CPCTC. So below, I have generated those two triangles that I want to start with initially. I'm given that CAD is congruent to angle EAD. I'm also given that angle C is congruent to angle E. And if I go back to the diagram, I know that segment AD is congruent to segment AD. So these two parts are common to both triangles. So on step 2, I can state that segment AD is congruent to segment AD by the reflexive property. And in the diagram below, you can see that I have the two triangles congruent. So step 3, I have EAD congruent to triangle CAD by the method of angle, angle, side. Therefore, I can state that segment ED is congruent to CD. By the method of CPCTC. Corresponding parts of congruent triangles are congruent. Then I can label angle BDC congruent to angle FDE by the vertical angle theorem. In the diagram, I can see that I have the two smaller triangles congruent, which tells me EFD, triangle EFD, is congruent to triangle CBD by the method of angle, side, angle. Step 7, I can state that segment BD is congruent to segment FD by CPCTC. My next proof, I'm given that angle ZXW is congruent to YWX. I'm also given that ZWY is congruent to angle YXZ, all indicated by single arcs and double arcs in my diagram. What I need to prove is that segment ZW is congruent to segment YX. From this given information, I'm given that triangle WLX has two angles congruent. And from the converse of the isosceles triangle theorem, I know that if two angles of one triangle are congruent, then the segments opposite those angles are congruent. Therefore, in step 2, I can state that segment WL is congruent to XL. And that is by converse of the iso triangle theorem. Now, the segments I need to prove are contained inside the triangle ZLW and YXL. I already have an angle and a side that are congruent inside those two triangles. I can state on step 3 that angle ZLW is congruent to angle YLX. And that reason is vertical angle theorem. That allows me to state that triangle WLZ is congruent to triangle XLY by the method of angle, side, angle. The side is included. On step 5, given this correspondency, I can state that ZW is congruent to YX. By the method of CPCTC.